Good morning students. Today we are going to discuss about module number 2, that is network theorems. Here we are going to discuss about that problems on Norton's theorem. So look at the problem. For the given circuit, determine the current flowing through the 10 ohms resistor using Norton's theorem. So for the given circuit, determine the current flowing through 10 ohms resistor by using Norton's theorem. Here we have to find out that what is the current which is flowing through the 10 ohms resistor. So the current which is flowing through the 10 ohms resistor, if you want to find out, means according to the principle of Norton's theorems. So as we know that according to the principle of Norton's theorem, that is the Norton's equivalent circuit. Let us see that what is the Norton's equivalent circuit. According to the statements of Norton's theorem, this is the Norton's equivalent circuit where a Norton's current source IN is connected in parallel with RN, and Norton's current source value is equal to short circuit current, and Norton's resistance value is equal to R equivalent value. Now our aim is to find out that the current flowing through the 10 ohm resistor. The current flowing through the 10 ohm resistor, if I want to find out, means before that I want to find out that Norton's current value. So to find out the Norton's current value, here I am showing that equivalent circuit diagram. I am replacing the 10 ohms resistor here. I am just short circuiting that terminals. If I am short circuiting the terminals, then a short circuit current which is flowing in the terminals AB, therefore the short circuiting current is equal to Norton's current, or the current which is flowing through the terminals AB is also called as Norton's current. So I want to find out that what is ISC or what is IN or what is IAB. So to find out this IN, ISC, IAB in this circuit, let us imagine the currents. If you imagine the currents here, a current which is driven by this 9 volts voltage source, let us assume it as I1, and I1 is divided into two currents, say as I2 and one more one called as I3, and it is also called as Norton's current IN. So our aim is to find out the current called I3 or IN. How to find out I3? We can find out the I3 value by using the current division rule. Therefore here I3 is equal to total current I1 into opposite branch. For this branch, opposite branch is 3 ohms. 3 divided by total resistance 3 plus 2. So in this formula, here I want to find out that what is the total current I1, that is this one, which is driven by this 9 volts voltage source. To find out that the total current which is driven by this 9 volts voltage source, that is I1, then what is the formula? To find out that I1 here, I1 is equal to, I1 is the current which is driven by this 9 volts voltage source. I1 is equal to the formula V by R equivalent value. This V is equal to this 9 volts voltage source. Then what is R equivalent value here? To find out the R equivalent value, according to our currents, whatever we are referred, so that is I1 is the total current which is driven by this 9 volts voltage source, and this I1 is divided into two currents. I2 is the current which is flowing through this 3 ohms resistor, and I3 is the current which is flowing through this short circuit path or 2 ohms resistor. So according to these currents, so in these branches, what is the relation? The relation in these branches here, 2 ohms is connected in parallel here. If I want to find out here R equivalent value, because of the different current like I3 and I2 which is flowing in 2 ohms and 3 ohms, therefore 2 is parallel with 3 and again it is series with 1 ohm. So what is that? It's a R equivalent value. When 2 is parallel with 3 and again it is equal to plus 1, then R equivalent value, that is equal, when 2 is parallel with 3, that is 3 into 2 divided by 3 plus 2 plus 1. So it becomes 6, 3 2s are 6 by 3 plus 2 5, 6 by 5 plus 1, 6 by 5 plus 1 means it becomes 11 by 5. 11 by 5 means it is almost equal to 2.2 ohms. So therefore here it is 2.2 ohms R equivalent value. If R equivalent value is equal to 2.2 ohms here, next what is the total current? The total current which is given here is Vs divided by R equivalent. Vs means 9 volts from the given problem. R equivalent is equal, just now we are calculated, that is equal to 2.2. Therefore the total current which is driven by this 9 volts voltage source, that is 4.09 amperes, that is total current IT, or according to our reference it is also called as I1. Now our ultimate aim is to find out the Norton's current. How to find out the Norton's current? As we just now discussed that to find out the Norton's current, here Norton's current IN value depends upon total current value, that is I1 into opposite branch resistance 3 divided by total resistance, that is 3 plus 2. So now I got I1. So just now we are calculated I1. The value of I1 here it is 4.09 amperes. Use that I1 or IT, that is equal 4.09 amperes, and find out the Norton's current called as IN. Therefore IT, in the place of IT I am substituting that 4.09 value here and 3 by 5. 4.09 into 3 by 5, it becomes 2.45 amperes. Therefore the short circuit current ISC is equal to IN, that is equal to, or the load current IL according to the terminology which has been used in the given problem. Now our ultimate aim is to find out the Norton's resistance. So to find the Norton's resistance, how to find out the Norton's resistance? Here we can find out the value of Norton's resistance Rn with the equivalent circuit what I am showing at here. So in this circuit I want to find out the Rn. Rn is also called as RTH. The method what we are using to find out Rn and RTH is same, that is nothing but R equivalent value. How to find out the R equivalent value for the given problem? To find out the R equivalent value for the given problem, here in the given problem there is a 9 volts voltage source. This 9 volts voltage source I am just short circuiting here and replacing that circuit, remodified the circuit can become as like this. In the place of 9 volts voltage source, by considering its internal resistance I am short circuited, and the terminals AB is open circuited, and from the terminals AB onwards I want to find out that RTH, which is also called as Rn. So now what is the value of Rn? To find the value of Rn, I want to know about the relation between 1 ohm, 3 ohm and 2 ohm. What is the relation between 1 ohm, 3 ohm and 2 ohm? To find out the relation between 1 ohm, 3 ohm and 2 ohm, let us imagine the currents how it will flow if there is a voltage source across the terminals AB. If there is a voltage source across the terminals AB, it drives a current. Hence the current is called as, for example, total current IT. It meets this node. After this, the total current IT is divided into two currents. One current which is flowing in this branch, name it as I1. The another current which is flowing through the 3 ohms, name it as I2. Therefore now the relation between 1 ohm resistor, 3 ohm resistor and 2 ohm resistor, that is here 1 ohm resistor and 3 ohm resistor are connected in parallel, and again it is series with 2 ohms. According to this relation, if you look very clearly, the value of Rn can become as, that is 1 is parallel with 3, so 1 into 3 divided by 1 plus 3, and again it is series with 2, so plus 2. So 3 by 4 plus 2. Therefore Rn or RTH is equal 3 by 4 plus 2. 3 by 4 plus 2 means 11 by 4, and it is equal to 2.75 ohms. If it is Rn value is equal to 2.75 ohms, then recall that Norton's equivalent circuit. In Norton's equivalent circuit, it consists of a Norton's current source whose value just now we are calculated and is equal to 2.454 amperes, and there is a Norton's resistance Rn value and whose value is equal to 2.75 ohms. which is connected across the terminals AB, and terminals AB now it is connected to the load resistance of 10 ohms according to the given problem. Now what is the current IL here? To find the current IL it here, again here we have to approach current division rule. According to that current division rule, the current in this branch of RL 10 ohms, that is IL is equal total current IN, that is 2.454 into opposite branch resistance is 2.75 divided by total resistance 2.75 plus 10. If you do the simplification here, and we got here 0.529 amperes. So 0.529 amperes is the ultimate answer for the given problem, and this is the way how to find out that solution when we are using the Norton's theorem to find out the unknown current in the given branch. Thank you.